All right, in this section, we're going to take a look at addition polymers. In addition polymerization, monomers add together to produce the polymer. No other products are formed. This process is initiated by a free radical, which is a species with an unpaired electron. All right, let's look a little more detailed at this addition polymerization process. As an example, the hydroxyl radical, and here's the radical right here, has this unpaired electrons. It attacks and breaks the double bond, so we have a carbon-carbon double bond of this ethylene molecule. And what it does is we get a single bond to the OH, and then this carbon has a full octet, and the second carbon now has a single unpaired electron. So we've created a new free radical. So a radical is a species with a single or an unpaired electron. Okay, so we have added this OH to the ethylene, and we have no additional product. One of the electrons for this bond comes from the carbon double bond, and the other electron from the carbon double bond is now an unpaired electron. So you can imagine this bond having two electrons. One goes here to form a bond, and the other now is unpaired. Okay, so now that we've created this new radical that you saw in the previous slide where we have this unpaired electron on this carbon here, this new radical can attack and bond with another ethylene molecule. So what happens is this unpaired electron comes here to break this double bond again, and then we get another unpaired electron here, okay? So we just get this growing chain polymer. Repetition of this process thousands or millions of times creates a long chain polymer. In this case, it's polyethylene. Chain growth in addition polymerization is terminated when any two free radicals react to form a covalent bond. The unpaired electrons in these two free radicals, one here and one here, join to form a covalent bond that you can see here, resulting in a stable molecule. At that point, there's no longer any free radical, and the ongoing chain reaction stops. Polyethylene is the simplest and one of the best known polymers. We went through the example of using a free radical OH to break the double bond of the ethylene a couple of slides back. We can see what happens here. We can take, this is ethylene, this is a monomer of ethylene. N would be the total number of ethylene monomers. It's a very large number. We add some catalyst, right? And in the example we showed a few slides back, we catalyzed or got that reaction started with that OH free radical, but it doesn't have to be that. So some catalyst needs to be used to break this double bond to create single bond n number of times. So we just make this very long polymer of ethylene monomers that are called polyethylene. Polyethylene is a tough, flexible plastic that is used for piping, bottles, electrical insulation, packaging films, garbage bags, many, many uses for this tough, strong, flexible plastic. Substituted polyethylenes also exist. So properties of a polymer can be varied by using substituted ethylene polymers. And what that means is you substitute the hydrogens for some other element. So when tetrafluoroethylene, meaning we have 4 fluorines and then carbon-carbon double bond, when that's the monomer, we get this polymer. Remember, we have some catalyst here where we break the double bond, and this polymer that we create is the trademark Teflon. Teflon can be used for making gaskets, valve seals, bearings, high temperature coatings like on nonstick cookware, along with many other things. Polypropylene is also a polymer, but it is stronger than polyethylene. Here's what the monomer unit looks like. It has 3 carbons, and there's a double bond carbon-carbon on one end. Remember, we just have n numbers, a large number of these units. Through some catalyzing event, can break that double bond, and we have multiple monomers connected. So there's 3 carbons, right? So 1, 2, 3, 1, 2, 3, connected by a single bond, and just repeating n number of times over and over and over again. Being stronger, polypropylene is used for making ropes, fibers, bags, pipes, and bottles. You can see some examples on the screen. Another polymer that we can make through this addition process is PVC, or polyvinyl chloride. PVC is a high volume polymer that is constructed from the monomer of vinyl chloride. So on the left right here, this is the monomer of chloroethylene. So it's ethylene with one of the hydrogens substituted with chlorine, has a common name, vinyl chloride. So n number of monomers of that. Through some catalyzing process, we can break the double bond to create another single bond to attach another vinyl chloride molecule or monomer. So again, this is with the double bond removed, and then repeating over and over and over and over again. That long chain polymer is known as polyvinyl chloride, or PVC. PVC is used for making plumbing pipes, records, handbags, plastic dolls and toys, curtain cloths, raincoats, vinyl flooring. You can see some examples of that here. Here's some flooring, a record, some PVC piping. So many, many uses of this polymer. Polymethyl-methacrylate, or PMMA, is a tough, transparent polymer that can be molded. Other names for it include perspex, lucite, acrylate, and plexiglass. It is made up of methyl methacrylate monomers that include this carbon-carbon double bond here in red. Some catalyzing event will break that bond, form a single bond to another unit of the monomer, and repeat over and over and over so that we get the polymethyl methacrylate, or PMMA. PMMA can take up beautiful colors and tints and be used to make lenses, lampshades, and plastic jewelry. Polystyrene is made of styrene monomers. So here's an image of styrene. So it's carbon-carbon double bond, right? like the starting of ethylene, but it's connected to this ring, benzene ring structure. It's called styrene. And the same process happens. We have to have something to break this double bond here so that we can attach and continue this chain reaction of addition of additional monomers to make polystyrene. Polystyrene goes by a common name, styrofoam, and it is used for making plastic toys, household wares, radio and television bodies, refrigerator linings, packing materials, many other things, as you can see. There are two general types of polyethylene, low-density polyethylene, or Ldpe, and high-density polyethylene, HDPE. Here are some facts about low-density polyethylene, or Ldpe. The chains contain many branches and thus do not pack as tightly as those in HDPE. It is manufactured under conditions of high temperature, 500 degrees Celsius, and high pressure, approximately 20,000 psi. Lower reaction pressures and temperatures have become possible through the use of catalysts. Product is highly linear and is often called linear low-density polyethylene. It is used to manufacture tough, transparent film that is used in packing consumer goods. High-density polyethylene, or HDPE, consists of mostly straight-chained molecules and is used for blow-molded products, such as bottles for consumer products. This shows the process for creating a blow-molded bottle using a high-density polyethylene tube, a die, and compressed air. So there's the die cast for the bottle. We put the HDPE tube in, we close it, we force compressed air, which molds it to that die, and then we remove the die and we're left with this blow molded bottle. Polyethylene's useful properties are the result of its high molecular weight or molar mass, the strengths of the interactions between specific points on the nonpolar chains are small. Its chains are so long that the small attractions accumulate to a significant value, so they stick together tenaciously. However, it becomes more difficult to process as its molar mass increases. Here are some common synthetic monomers, polymers, and their uses. We've seen many of these in detail: ethylene monomer, polyethylene polymers, and the uses in piping, bottles, electrical insulation. We also looked at PVC, or polyvinyl chloride, which comes from vinyl chloride monomers, used in piping, siding, floor tile. And one we didn't look at was this acrylonitrile monomer, which forms polyacrylonitrile polymers used in carpets and fabrics. So here's a couple others that we saw in detail. We saw Teflon and polystyrene, but we didn't see this one, butadiene, which you see the monomer here, produces polymers of polybutadiene used in tire tread and coating resin, and synthetic rubber, which comes from monomers of butadiene and styrene. So it's a styrene butadiene rubber, which is a synthetic rubber. You can see, it says C above here, you can see that this is a combination of the styrene and the butadiene. So here's the styrene, butadiene. Let's talk now about some other synthetic polymers. There are many synthetic rubbers with certain desirable properties. Buna Rubber is a copolymer of butadiene and styrene that is mainly used for making automobile tires. Butadiene is polymerized in the presence of sodium to produce a rubber-like substance called Buna. This was used in Germany during World War II as a rubber substitute. So we have a butadiene monomer here on the left, or the IUPAC name is 1,3-butadiene. Many monomers of it that form this chain polymer from known as Buna Rubber. Bu in the name comes from butadiene, and the Na comes from sodium. Okay, so in the presence of sodium, we can create this butadiene polymer, or Buna Rubber. Neoprene rubber is made by the polymerization of 2-chlorobutadiene, or chloroprene. So we can see this chloroprene here, or 2-chlorobutadiene. It's used for making knee braces, insoles, wetsuits, dry suits, safety gloves, small boats, boots, etc. So that neoprene feel, like on a wetsuit, or those neoprene safety gloves that you might use in a lab sometimes, are made from this monomer polymerized into neoprene rubber.